Hey guys, so in this video we are going to create the target spawners, which are basically the objects responsible for creating targets from time to time. So let's start. Let's start by checking the game in Scratch once again. So we know that we have 3 different target types, and basically here in Scratch we don't have target spawners, so you can see that we only have the target objects or the target sprites here. And basically this is because Scratch has the concept of clones, which is basically when that a sprite can create copies, or where we can create copies of a single sprite. So in a way, here in Scratch, what I have is that the code of my sprite is actually working as both the sprite and the spawner. So you can see that this block right here is working as a spawner, so is the code responsible for creating the targets, so it's spawning the targets, and these blocks right here are actually run when they are a clone, when they are a copy of that sprite. This is a concept that Scratch uses, so basically we can have sprites and we can create copies of that sprites by that they call clones. In Unity we don't have that. So in Unity we are not going to have just a single object which is a target and that is responsible for creating copies of itself. What we have is that we have a target, which we created in the last video. So we have a target with its own behavior, and we're going to have a different object, a different game object, which is a target spawner, which is going to be responsible for creating copies of the target that we have. So basically what we are going to be dealing with is this code right here. So when we receive the start game, when the game starts, we are going to run forever, like in a loop. We are going to be creating copies of the target sprite from time to time. So you can see that here, for example, I'm just creating random, I'm waiting for the random number of seconds from 1 to 3 seconds. I'm waiting randomly from an amount of time, and then I'm creating copies of the target sprite. Now let me just check here. So basically the comparison between the nodes, the blocks and the nodes that we are going to use. So we have in Scratch we have this forever block. In Unity we are going to use the while loop block, which is basically a node that runs whatever it's connected to the body output of this node. Whatever all the nodes that are connected to this body, or the flow that is connected to this, is going to be called in a loop, just like in the update. So if you remember, on one of the first videos we used the onUpdate event node as the most closely related to the forever block, and in a way they are both similar. The only difference is that the onUpdate node is a life cycle node, so it's a node that is an event node. So it's an event that belongs to the life cycle of the game object, of the mono behavior, which is called internally by Unity. So we know that onUpdate is being called by on each frame. The while loop is a way for us to create a loop when we want. So it's basically, this is not called by an event, it's not called by Unity or the lifecycle of the mono behavior. Basically we can just connect this loop inside a flow of nodes, and we know that whatever is inside will be run in a loop. So it's also in a way works in a way very similar to the forever. The only difference is that while on update it actually runs forever, so it runs while the game is running. We know that on update loop is running forever. On the while loop, the difference is that it runs depending on a condition. So when a condition is true, the loop runs. If the condition is false, the loop stops. That's the main difference, but it's still closely related to this forever block. Then we have the blocks for when I start as a clone and to create clones. Once again, Unity does not have the concept of clones, but we have the concept of game objects. So when we want to create objects in Unity, basically what we need to use is this node game object instantiate. So basically we are going to instantiating or creating new game objects. Then we have the block to wait a few seconds, and we also have a node to wait a few seconds, so they are almost the same. And we have the random block, so choose a random value from the minimum value to the maximum value, and we have the random range, which is almost the same, so choose a random value between the min and the max. So let's go back to our project and start creating this. So we already have the target, we created the target on the last video. what we need now is to create the target spawner. So like I told you, this is a little bit different from Scratch. So in Scratch we have the code to create copies of the target inside the target sprite. In Unity we don't have that. So in Unity we need a separate game object to create the copies of the target, which we are going to call the target spawner. And in Unity we use a lot, this is a different from Scratch. In Unity we use a lot of empty game objects. And empty game objects we already used it before when we were creating the game manager. So we know that this game manager is basically an object that exists in our scene that only has code. So you can see that it does not have a sprite applied to it. In Scratch this is not possible. I mean, it's possible, but you can have like an empty sprite. And I used it in this project. You can see I have this game manager in Scratch, which is a blank sprite. So, but basically Scratch, the concept is that everything in Scratch inside our canvas is a sprite. Everything inside our project is a sprite. In Unity we don't have that, so we can have an empty game object. So we use a lot of this for when we want game objects in our screen that basically only have code. And this is what we are going to use for the target spawner. So we need to create a new empty game object. Let me check. So we are going to call it target spawner. And I'm just going to position it at the origin of the scene. You don't need to do this, but it's just like a convention. Even the game manager is like not on the origin. I'm just going to position on the origin. So to position the game object on the origin, we just need to set the position to 0, 0, 0. And we know that this object is on the center of our scene. Doesn't make any difference. It could be like anywhere in our scene, because this is just a holder for components for the scripts in this case. But either way, it's a good convention to have this at the origin. So I have this target spawner, and now we need to create a new graph. So let's create a script machine in our target spawner, create a new graph. So on the scripts, and I'm going to call it target spawner. And now we are going to edit this graph. And basically what this graph is going to make is going to create copies of the target. And like we were saying before, we have this node called Instantiate, and we need to use Instantiate game object. And basically this is the node that we use to create copies of a game object. And let's just connect this here just to try it out first. And basically what we need to add to this node, you can see that original cannot be null, so you have an input right here called original, and this is basically, okay, what object do you want to create? And the object that we want to create is this target that we have right here. Now I need to introduce the concept of prefabs. Prefab is a concept that Unity has, which stands for prefabricated objects, if I'm not mistaken. And basically it's a way for us to reuse game objects in our projects. So let me just show you, for example, what I mean. Prefabs have different advantages of using prefabs. One of the main advantages is that prefabs creates, like I said, reusable game objects, and one of the advantages is that you can create linked copies of an object. What I say by this is that, for example, let's say that in this game I would want to have like a lot of these different targets. So forget the spawner for a moment. I just wanted to have like a lot of these targets in my game. So I could just come here, like copy paste the targets and do something like this. Or in Unity we usually don't copy paste, we duplicate the object. So you have like this duplicate or Control D. We duplicate this, and now I have like 4 copies of my target in my game. Now let's imagine that I want to change something in all my targets. You know, like I want to add a new component, remove a component, change some values in one of the components, whatever. If I change on a single target, I need to make, let's say, for example, I want to disable the sprite render. I want to disable this, and I would have to go to all the other ones. Of course, I could just select all and just disable all the sprite renders. And that's okay because it's a really simple setup, but as you can imagine, we have a lot more complex setups when you are working in Unity. So imagine that all these targets are not like all of together right here, but they are scattered through my scene hierarchy. And it's really hard to just, okay, I need to select all of them, and I can just forget to select one of the targets. And this will be a mess. And so Unity has this concept of prefab, which is basically I can create a template of an object, a prefabricated object, and create copies of that template. And when I create copies of that template, those copies are connected to the original object, which means that if I make changes to the original object, meaning the prefab, if I make changes to the prefab, those changes are applied automatically to all the copies. Let me show you what I mean. So first, how to create a prefab. Creating a prefab is really easy. I'm just going to create a new folder for the prefabs. And to create a prefab, you just need to select the object that you want and drag it into the project. Anywhere. I mean, I created a prefab folder, but you could just drag to any other folder, it would create a prefab. And now you see that you have this blue cube here. This is a prefab. And you can see that the copy that I have in the hierarchy is also blue, which means that this is a copy of this prefab. What do I mean by a copy? If now I duplicate this, you can see that I have the same as before. So I have like my 4 different targets. Now the main advantage of using the prefab is that if I now came here to the original object, to the template, and I disable the sprite render, it automatically disables and applies the change to all the copies. So when I say that these are linked copies, so which means that all the changes that I make to the prefab, they are applied to the copies of that prefab. This is the main concept around the prefabs. I could go a lot deeper into this concept. This is not the goal of this video, but just so you know what is a prefab. And why am I talking about prefabs? Because we need to use prefabs when we want to instantiate objects. Now I was deleting everything, because in the target spawner, we need to tell it, let's go back here to the script graph, we need to tell it, okay, what objects we want to instantiate. And to do this, first, what we need is a public variable that we can assign the prefab or the object that we want to instantiate. Once again, we cannot choose it from here, because if we choose it from here, then we cannot reuse this target spawner to create all different types of targets that we want. And we are going to need to have 3 different target spawners, one for the target in the back and 2 others for the different ducks. So if we have different objects to instantiate, we need to create a public variable where we can just say, okay, this spawner is going to instantiate this type of objects. So let's create a new public variable. When I say public variable, it's an object variable, and let's call it prefab, which is of the type game object. And now we are going to assign this to the original. And it's still complaining because the variable is still null, so you can see the value is none, so the game object is still complaining. But now if I come here to the target spawner, I can just come here to the variables and assign a value, an object there. Now, I could just assign it from here from the scene, but the problem is that if I have the target already on the scene, then when the game starts, I have this target right here, and I don't want that. So I'm going to delete it because I already have the prefab right here, which is the template of the target. And in the target spawner, I'm going to say, okay, we are going to create copies of this prefab. So basically this is another advantage of prefabs, that you can have these templates of game objects that are not present on the scene when you start the game, and that you can use these templates to create copies at runtime while the game is running. And this is usually the best way. Of course, you could just like disable the game object in the scene and apply it there, but that's not a good way to do it. So you need to create a prefab, give it as a reference or as a blueprint or a template to the script that is going to instantiate it, and then it's going to create this target spawning, is going to create copies of that prefab. Okay, so now when the game starts, it's going to, this target spawner is going to create a copy of the target. Let's just see if it's working. And yes, we have our copy. You could see that it created the target clone, and now it's moving. And it's going to destroy itself when it goes out of the screen. Okay, so the target spawner is working. Now what we want is that we don't want to create a single prefab, but we want to be creating targets while the game is running. And to do that, we cannot use the onUpdate event because we need to wait. Let me just show you here. because when we are creating the targets, you can see that we are creating forever. Okay, inside a loop, we are creating copies, but then we need to wait for a few seconds before creating the other one. Because if we are just creating prefabs every frame, it's going to be like impossible. The game is running at like 400 frames per second, so we'll be creating like 400 targets per second, which is, we cannot do that. So we need to wait between each instantiation. Yeah, I think it exists. But we cannot use onUpdate because onUpdate is called every frame, and we cannot wait inside on a onUpdate event. So we need to create another loop with this node, which is called the while loop. And this is basically, let's just create a loop, just like the one or similar to the one that we have on update. So whatever we connect here to the body is going to run, in this case, every frame, but we are going to actually wait before starting again the loop. And what runs here in the while loop, we have all these inputs and outputs. So basically we need to connect this here. So when on start, we start our loop. The exit is what we run after we end the loop. That's not what we want right now. What we want is what's connected inside the body. So what's connected to the body is what is going to repeat itself while the loop is running. And you can see that it's complaining because the condition is missing. Like I told you before, a while loop needs a condition. So the while loop runs while a certain condition is true. While it's similar to the if condition, so whatever is inside an if condition runs if the condition is true. The while loop is quite similar, but instead of running only once, it runs forever while that condition is true. And in this case, just for testing, let's start with just a true value. So we can use like a Boolean withdraw to say, okay, while true, and this is basically say, while true, run this. Now, the problem is that if we run this right now, it's going to be exactly the same as running on update. So this is going to run every frame. So it would be instantiating objects on each frame, and we don't want that. So what we want is that after we create the object, we want to wait for a few seconds. And we have this node, wait for seconds, and now we can give it a delay. So let's say let's wait for 2 seconds. Now, the only problem here, and I'm going to run the game just so that you can see that it automatically complains, so you cannot even make it work like this, which is really good because you don't forget to enable what we are going to do next. You can see that the game is already paused automatically when it started. You can see that this is red and it says, okay, invalid operation, even here on the console, port enter, blah, 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 can only be triggered in a coroutine. Okay, so basically, I'm not going to get into a lot of detail about the coroutine, but basically a coroutine allows you to wait to use this wait for seconds and to wait for something inside a while loop. What happens is that if you just wait here inside a while loop, what would happen if this was if Unity actually let this work like this? What would happen is that you would be using this wait block, and you would be stopping the game for 2 seconds. All the game would stop for 2 seconds before starting again the while loop. So basically you would be blocking the game execution by using this wait node connected to a while loop. So what you need to do to prevent this is come here to the original node, the event node that you are using, and all these event nodes have this coroutine check. And you need to enable this checkbox so that you can use this wait for seconds inside a while loop without breaking the game execution. I'm not going to get into a lot more detail about this, but just remember this rule. So if you are using a while loop, or even on an update, you also have like this coroutine. If you are using a while loop, you usually need to, and you are using a waiting node inside the while loop, you need to use this coroutine check on the original event. So now, if we run this, I think it's still not detecting, but now if you run the game, it's going to probably work. And now you can see that, yes, it's basically instantiating targets every 2 seconds. You can see that it highlights every 2 seconds and basically, okay, this is true, the condition is true, it instantiates a copy of the object, waits for 2 seconds, the condition is still true, creates another one, and it goes like this forever. Okay, so we have our target spawner working. Now let me check what we need to do. Okay, yeah. Now what we need to do is we are not going to wait for a specific amount of time. If we go back to Scratch, you can see that basically each target is waiting for a different time amount. So you can see that actually these two are with the same 1 to 3 seconds, this one, and the one in the middle is like waiting just 1 second. But basically what we need is a way to wait for a random number of seconds between each instantiation. So first, if we want to configure the mean seconds and the max seconds, we need variables for that. So let's create object variable for that, and let's say mean seconds or mean wait seconds. Let's pick a melhor. Sorry, I'm still talking Portuguese. I think it looks better this way. Mean wait seconds, which is can be a float, yeah, and we can create a max wait seconds, which is also a float. And now we need a way to generate a random value between this mean and this max value. So first, let me just grab these values here. So we have mean wait seconds and a max wait seconds, and we have a node for that, which is a random range. And we could use since these are floats, we can use this mean inclusive and max inclusive, because we are using, basically we have two different random ranges. So you can see that if you are using float values, I mean decimal values, the value that you're going to use is going to be inclusive of the mean and the max. And if you use an integer variable, you can see that, which is using integer input, so I mean whole numbers, when you are generating numbers, it's going to include the mean number but exclude the max number. So if you are generating an integer, a random integer between, I don't know, 0 and 3, you are going to actually get values from 0 to 2. So 3 is exclusive, is excluded from the range. If you are using decimal numbers from, I don't know, 0 and 2, then you're going to have values from 0 and 2, but decimal numbers. And this is what we want right here, because we want like I don't want to generate numbers from, or to wait seconds from like 1 second or 2 seconds or 3 seconds, but I want to wait 1.1 or 1.2, 0.5, 2.3, whatever. So I want to use decimal numbers. So mean, and we are going to get the output and assign it to the delay. And now we have a random value between the mean wait seconds and the max wait seconds. And what we need to do here is we need to, on the target spawner, we need to configure it. So I want to wait between 1 second and 3 seconds, which were the ones that I was using in Scratch. So let's see. And now the targets should not be instantiating like it were before, like every time. Yeah, okay, these are closer together, these are far apart, so you can see that now the distance is not always the same, so they are not being instantiated at the same time. So you could see, yeah, actually you could see here, okay, it weighed 2.11, 2.62, 1.59, this is what we want. Okay, so we have our target spawner, we have a prefab for our target, we are instantiating the prefabs, we are waiting for seconds, we are waiting for a random value of seconds. What else do we need? Oh, we need to set the position. This is something that I also did here in Scratch, that when we start, we can see that this target is right here, this target is a little bit lower, and this one is in the middle. So, but basically what I did is that when we start, let me check, you can see here, I'm using a random value for the Y position of the target. So I didn't want my targets to always be at the same height, because that would be easier for the player. So basically what I'm doing is that when I'm instantiating the targets, we want our targets, I don't know, this target's going to start here, this is going to be a little bit up and a little bit down. So it creates a more random, or a more, I mean, a random position for our targets in terms of the Y position. And to do that, basically we need to set the position. After creating our game object, we need to set the position of our game object using a random value. And first, let me check. Let's just disconnect this. And to set the position, we already know that we have this node set position, transform set position. And basically what we want is we want to add an offset to our position on the Y axis. And to add an offset to our position, basically first what we need is a new variable that where we are going to define what's the max offset that we can give to our object. So we are going to position the target spawner at the minimum height that we want our targets to appear, and then we are going to give it a max offset, and we are going to generate a random value between the current position of the target spawner and that max offset, and we are going to apply that to the position of the object. So let me just check here. I'm just going to check how I did this before because I don't quite remember right now. And yes, okay. So basically what we want is we are going to transform set position. Now what we need to change here is that we don't want to set the position of this transform, but basically what we want is that we want to set the position of the object that we just instantiated. So basically we can use that object from here. So you can see that the game object instantiate has this output right here, and this output is basically gives us the object that we just instantiated. So we can say, okay, I'm going to use that object and I'm going to transform and I'm going to set the position of that object by a certain value. And now what we want here is that we want the position. We are going to use the position of the game object of the target spawner, and we are just going to add a random offset. First we need a variable, let's say max offset y, which is basically the max offset that we can apply to the y position of our object. Let's say float variable. I'm just going to bring it here. Then we also need, just going to remove this from here. Then we also need to what? A random node. Yes, we need a random node because we're going to be generating an offset between 0 and the max offset that we want to apply. And it's going to be min max inclusive. So the minimum is 0 and the max is going to be this one, which is okay. And now we need to create a position from this one. So let me just check. Okay, we are going to create a vector2. Sorry, a vector2. It's a width row. Oh no, not a width row. It's a create vector2. Okay, we are going to create a vector2, and basically what we are going to do is, oh, I cannot get the x value from here. Yeah, okay. Yeah, I cannot create the x value. Okay, so let me just check. Vector3, expose vector3. No. I need to get x from the position that we have. So vector3, get x. I'm just going to explain all this in just a moment. And then I'm going to apply whatever we have from here. And I'm going to apply this position to our transform. And wait, I'm just hoping that this is all correct, but we are just going to test it in a minute. And I'm going to move this up. Oh, I forgot that this moves as a group. Okay. So basically what we are doing here is we are creating the object and we are changing the position of the object that we just created. And we are changing that position by, so the position is going to be exactly the same as the, in terms of the X position, is going to be the same as the target spawner. So we are getting the position of the target spawner, getting the X value of that position, and using it on our new position that we are going to apply to the instance, to the target. And we are generating, actually, we still need something here, which is a get y. We need to use a get y here and apply it here. Okay, because I was using 0, but we cannot use 0 because otherwise we are generating a value between 0. Sorry. Okay, this is getting really complex because then we cannot use just the max offset, because what we want is that we want to generate an offset of the y position between the y position of the spawner plus the offset, not from 0 and the offset. If we do something like this, then imagine that our target spawner is at like 30, our offset is like, I don't know, 10. So it means that we are generating from a random value between 30 as a minimum and 10 as a maximum, which does not work. So basically what we want, and this got really complex from like out of nothing, but basically what we want is we want a max offset and we want to use this. Let me just connect this here and here. And I think this is what we want. Sorry, this got really complex, but this is not actually crucial for the game. I mean, this is just a nice to have, but I was not expecting to get this complex. Basically what I'm doing here is that I'm applying the max offset. I'm adding the max offset to the current Y position of this spawner. So it creates the max offset that the object can have, and the minimum is the Y position, the current Y position of the spawner. So I'm generating a value from the current Y position of the spawner to the current Y position plus the offset. Then I'm generating a random value and I'm applying that to the instance. Okay, let me just check if this actually works or not. And now we need to position our target on the correct place. So if our target is positioned right here, it means that our targets are going to be positioned where the spawner is. So they are going to appear here plus the offset. If I don't change this max offset, let's just check, they are probably going to be instantiated exactly where we have our spawner, all at the same height. So you can see that they are all at the same height, which is okay. Now let's change, I don't know, the offset to like 60. I don't know how much I use. Yeah, I use 60 for the target spawner. And now probably they are going to be like upper and lower when they are instantiated. Okay, yeah, you can see. So basically, every time we create a target, we generate a random value between the position of the spawner in the Y position of the spawner and the Y position of the spawner plus the offset. And now our targets are being generated upper and lower. Now, the only thing that we need to do is to actually position our spawner in the correct place. And to do that, I'm just going to grab this here so that we can have a preview of where our targets are going to appear. Basically, I just added a copy of our target into the spawner so that now when I position my spawner, I can actually see where the target is going to appear first. And this is necessary so that we can just define, remember that where the spawner is going to be the minimum height of our targets. So we need to make sure that our target is positioned in a way that the target is not occluded behind the grass or the water, stuff like that. So probably, I don't know, here. So maybe this height here. So this is the mean height that the target is going to appear. And I want my target to appear from this position. And now I can just delete. Oh, and if it's plus 60, it means that our targets can go from here to this height right here, which looks actually okay. And now we can just delete this. And if we run the game, now our target should be in the correct position. And yes, this is what we want. And of course, now we need to change the speed because we don't want all these targets appearing in the game. Let me just check what values I used before for this one. So for the target, I think I had a really high speed. I had like 500 for this target. So let's just check how it works with 500. Because these targets in the back, they should be really fast and really hard to hit, because they are the ones who are worse than most. Oh, you can see that, right? Yeah, this is okay. Okay, so we have our target spawner that instantiates these targets. Now, I think the only thing that we are missing... Oh no, I was saying that we are missing creating the other spawners, but we are still missing something. That we don't want our target spawner to work right from the beginning. We only want the target spawner to work when the game actually starts, and we know that the game only starts when we press the label ready. So, and when we press the label ready, we are saying to the game manager, okay, the game has started. So if we come here to the game manager, just remember, we have this custom event that says, okay, start game. And basically what we want is that when we start the game, we start everything that we need, and then we need to enable the target spawner. So let's go back here to the target spawner. And basically what we need is that we need a new variable. We need a new variable that basically this while loop is going to run only when the game has started. So we need a new variable to control that, to control, okay, is the game started or not? So that in a way the while loop won't be active at the beginning, but we can use a variable, and then the game manager is going to change that variable of the target spawner so that it starts working. So basically, let's start by creating a new variable. In this case, is a graph variable because it's a private one. No one is going to change it from the outside. We are using an event to change that variable. So we have this game started, and instead of using the true value here on the while loop, we are going to use this variable. So when the game has started, this is going to run, and since it's false at the beginning, it doesn't start running at the beginning. Just check something here. And now we need to receive a custom event. So we are going to create a custom event that we are going to call enable. And this is going to be called from the game manager. So when we press the label, the label tells the game manager, okay, start the game, and the game manager is going to tell the spawner, okay, is going to enable the spawner. So we no longer are going to use this on start. What we are going to use is this enable, and don't forget to enable the coroutine. And now we need to change something here because we are not actually using this variable. Oh, we need to use this variable because we are going to enable and disable the game. But right now, if we use something like this, before actually using this and connecting to the while loop, what we need to do is to actually, let's not use the variable right now, or let's just check this variable as start, something like this, and then we are going to change this later when we are dealing with the game state, like pausing the game and starting the game or resetting the game. We are going to make changes to this, but right now let's just keep it like this. So let's just assume that the game has started from the beginning, but this will only start when we actually receive this custom event. And to receive this custom event, let's go back to the game manager, edit graph, and here on the game manager, we need to have a reference to the target spawner. So let's create here target spawner. And this is a game object. And basically we do all this, game started, and afterwards we are going to trigger an event. Trigger a custom event, which is an enable. And basically we are going to trigger this custom event on this target spawner that we have. Target cannot be null. Oh, because the target spawner is still null. And here on the game manager, we are going to say, okay, this is a target spawner. And now it's okay. And now let's test all this. Now I have my label, okay, the crosshair is hidden, I press the label, and now I have the target spawner working, and I have my crosshair and everything. Let me test again, because I think I actually pressed the label and it wasn't noticeable. Okay, so I pressed the label and it didn't start. And so this is it. And now what we are missing is creating the other targets and the other spawners. So, and to do that, I'm just going to create here. Okay, so we have this target, and basically, so we have the target spawner, and we are going to need the duck front and the duck back. And let me just check something before we continue. And probably we are going to do that on the next video, because this video is already too long, because I wasted too much time doing that offset and stuff like that. So on the next video, we are going to deal with creating the missing targets and all that before we continue with the rest of the game. So this is it for this one, and I hope I see you on the next one. Thanks.